I had this presentation on kotlinx-coroutines, whether it was designed both for backend and Android developers. This is an Android-specific version. We are all Android developers here, so it's a very different presentation. We changed it quite significantly. My name is Marcin Moskała. I am a consultant, a trader, contractor. Last couple of years I spent most of my time helping different companies deal with their issues, either just the piling behavioral issues or performance issues. I'm a GDE in Android, partner of Japanese for teaching Kotlin, author of already well-known course, Coroutines Mastery. If you haven't heard about it, we'll very likely hear about it soon. And author of 6 books about Kotlin, including kotlinx-coroutines-debug and effective Kotlin best practices. This presentation is divided into 3 parts. We first talk about observability for coroutines, then we will learn how to debug coroutines, what tools do we have for debugging coroutines, and finally we'll measure performance. Particularly, we will just look in coroutine-related code. I want you to understand that debugging is a process, because most people associate debugging with usage of debugger, but actually debugger is the last step and one of the least used steps in debugging. The most important tool for debugging is logging. Many people undermine logging. You so often hear about using tests for improving stack stability. Many newbie developers do not understand logs. They think it's something redundant and often remove it or forget about it. But actually logging, like whenever I have an application that where developers are scared of solving issues because there is a piling stacks of issues, introducing proper logging is the most important thing to do to improve that, to help developers understand what's going on when issue happens and to finally solve those issues. On Android, there are 3 ways how we use logs. Of course, we consider locally, so they can help us understand what led to exception. There are also services where you can send our logs, data goes one of them, or you can analyze how application works in your user devices. And there are many such applications. They are used for observing how users are using devices to detect different kind of issues. But on Android, the most practical the usage of logs is in services that are issue trackers like Firebase or Sentry. They all have built-in support for breadcrumbs. This breadcrumbs by default includes user interactions, navigation. However, if you add some logs, then it's also included. You can configure to include logs there. And if you do, you not only can see what user did, but you can also see what happened as a result of this interaction and in the application, which allows you to go much deeper and closer to the problem itself, which is very useful, especially since stack traces in kotlinx-coroutines are garbage. They are working on improving that, but they are not very good at the moment. Here I want to make you familiar with a technique that I use in bigger applications. You call it rich logs, and those are logs enriched with some extra data. It's a very common practice on backend, less common on Android, but useful in bigger applications. And I will present you to a coroutine specific implementation. Action learning here, and simply rubber that using with context and adds this context to the function. This context will be present in this function and all its children, and the function called the community started thanks to structured concurrency. So this way, everything that happens as a part of this action will have this context. Context can also be added to a coroutine also knows what Jordan started it, but you have it on context. How can you really present it on logs? So the simplest technique, oh, I'm sorry. You can also add coroutine name, which is a standard context from kotlinx-coroutines library. Or if you turn on debug mode, kotlinx-coroutines-debug, then every coroutine will receive this automatic coroutine ID context, which can also be helpful to determine if two logs are coming from the same function or from a different execution of probably the same function. And the same coroutine from different colors. It's quite lightweight, it should but that should be helpful for our application performance. So how can you read it afterwards? Every suspending function has access to its context. We can use that. One of the techniques that we are using is defining a custom logger, which is a wrapper with a logging library that we use. Many big applications use such wrappers because wrappers change. There is no standard wrapper in Android, so making a wrapper over that is generally a good idea. If you use a suspend functions, you can extract context from those suspend functions, and from this context you can easily find the keys, so coroutine name, action name, model name, coroutine ID, if you use them in your application. There are other things that can be attached to one obviously it's dispatcher, every coroutine is dispatcher, so we can always add it. The other two are also quite common in bigger applications. We often log some session ID. This session ID is unique to application start. So when you start an application, in application or in the CDI configuration, you just generate random string. It can be UUID random string. Or it can be generated in any way you want. The point is that it should stay the same for as long as this application is running, so you know that that's the same session, that's a different session. And another one is you might add some user ID, which can be very useful for reproducing this problem later. Instead of user ID, some applications just store again some random string that is generated when application was started for the first time. It's not to ensure preferences. I needed some dependencies for this logger, so how can I provide them? The simplest technique is to define some logging provider that is defined in our created in our CI, like going acute, and that creates a specific logger and with a tag and with some provide function. And this way, in a basic model, any class you can create a logger and use it. So if you have some, if you define some lazy model, you can define that model. So you can also override viewModel scope. That's another practice that if you want to have your own viewModel scope instead of the default one, you can define the basic model and attach a viewModel name. There are some other things that are that might be or might not be added. Just a note: you don't need to include this all in your application. Just decide what will work for you, what will be useful for you. And this is like a complete list of what you can just use a subset of that. So about viewModel scope, a similar story. That's a pretty basic viewModel scope, but what about exceptions that we do not catch? We might also want to enrich our exceptions. For that, we might define coroutine exception handler. Here's a very important note, because on Android, if you do not specify coroutine exception handler, there is a default one set up, which is breaking your application with any uncaught exception. You probably know about it. I understand this behavior was an implementation of offensive programming and made to make backward compatibility with how exceptions on thread also broke applications, but I just feel it's not a good solution for serious applications. In serious applications, you should track all exceptions. You should never lose them. You should work on them as soon as possible. But at the same time, if you have an issue on production, you don't want to completely break the application because it's not a good user experience. So I like defining my own coroutine exception handler and properly sending my exceptions to
to issue tracker, I can explicitly call sentry. If I want here, I just added my logger error. Another thing is that it's not uncommon on Android to add some default handling of exceptions. So you can have some representation of exceptions, actions that can be observed by your activity, and maybe to display a dialog or toast or navigate to a certain screen in case of certain kinds of exceptions. Such exceptions can be represented in a mutable shared flow with a channel, or with mutable state flow with a list of throwable. All those representations are fine. And the last thing that is often added is a dispatcher. I won't go too deep into that, but you can specify a dispatcher with a view model. Specifying dispatcher's default will make your application, well, slightly faster because you are you are not using a UI thread everywhere, but at the same time a bit harder to implement because you need to beware of synchronization issues. And you must not make UI changes on view models, which we typically don't because we update state, which then is observed in UI, which is fine. What about application scope? We often define application scope for starting background tasks in our application. It can also have its own logger, and it also we also might want to have a coroutine exception handler if we do not want each exception to break our application. How about other kinds of classes, repositories, use cases, services? We just define our logger and we use them. I also show a definition of an action that will enrich our logs. Okay, let's complete. This is a complete picture of rich error pattern that I use. Moving towards another section, I told you that debugging is a process, and for me it's a three-step process. First, we need to observe bugs, so we should track all exceptions and you know, take care of them, never ignore them. Another one is to reproduce. In simpler applications, we just try to reach the same situation as we observed in the application. Sorry, as we observed in our users. However, in serious projects, there is this very common practice that I would highly recommend to you, that every issue that we observed in our user should be reproduced with a test, meaning that we should implement a test that is failing because of this issue, but should be passing if application would work as expected. Sometimes it might be hard if it relates to our backend service, then we need to mock responses. Sometimes it is easier if we have an issue in our domain layer. We can just write an unit test and reproduce it locally. Nevertheless, it's a good practice to reproduce it. And when we can reproduce it, that's the point where we can open our debugger and finally investigate this issue. So let's see how we debug things. I will open IntelliJ in here. Maybe, sorry, I will make it a little bit bigger. I realized it's not in the presentation mode. So I know it might be small to some of you, but there are a few things I want to show. So I decided to keep it this way. Imagine that you write an application. This is more a backend side, but it shouldn't be a problem. An application where users can order some ebooks. And after you published it, you receive information from a user that he purchased an Kotlin-coroutines in Polish language, but he received it in a different language. He received a different book. So you reproduced it. You asked to create an order and specified what you expect in a result. And what's that? Oh my. Okay. I just made merge with the main branch. Okay, so you can see that this test is failing. The book that you expect is a different one from the one that you receive. So let's investigate that. We'll investigate it by starting it in debug mode. To do that, we typically use breakpoints. Breakpoints stop execution of our application. By default, they stop all the threads, so all our application should be frozen. From a breakpoint, you can navigate to another place in a couple of different ways. One way is to make another breakpoint and go there. However, beware, if you have multiple coroutines executing this function, another coroutine might be caught on this breakpoint. You can also use those tools, like there is step over, which goes into another line at the same function. In Kotlin coroutines, it guarantees to be another line of the same function in the same coroutine. That's a new thing introduced quite recently. You can step into a function, yeah, so this is a function that we just called. We can step out of the function, so we are back at our create order, or you can navigate to cursor. At any point, you can see all the data, all the local variables. Notice that in production environment, most of those would be optimized out, but since Kotlin 2.2, by default in debug mode, local variables are never optimized out, so you can see everything. That's a nice improvement. You can also see those values like that. Let's see what we have in our request. Our request expects a book in Polish. Let's see what we received from our ebook. Counts as ebook. You can see we have a book in English, so probably the problem is somewhere in here. Let's start it again. This time we stopped our application at this point, and let's see what this function gives us. Of course, we could see the variable, but I can also execute all kinds of functions, including suspending functions in my local in this place. So let's see what we provide. We provide key. It.key is of course coroutines, which is the same as ebook.key. So this is fine. Yeah, you can see they are equal. The result is true, but their language is different. Yeah, so ebook it.language is not the same as ebook.language. So we are quite clearly missing a language on this function. Let's check the parameters. You can see this function also expects a language, but it used a default value, language en. If we specify language as well, we'll have a proper ebook shown return, so ebook with language PL. So that's our correction here. Pretty simple one. We just need to add our language PL. And we can also correct this function to not confuse anyone else. If ebook is identified by both the key and language, then language shouldn't have default value. So now our test should pass. Okay, another day, another problem. Another user told you that he he purchased ebook and he received an email, but an incorrect email. Sorry, this email haven't got a link to your ebook. So you reproduced it with the following function. And there are ebooks. You make an order, you confirm it, you advance until idle to await the coroutine completion, and you expect the result email what got sent, but it doesn't include the links that you expected. So let's see a confirm function here. This is a function that starts a coroutine on a background scope. It starts a bunch of other coroutines. So let's debug the behavior of those coroutines. In the debugging tab, you have a bunch of options. Among them, you have, where is my, yeah. I normally have it on the bottom, and it looks like it's hiding some of my options in here. Because I should be able to see here debugging, to see here a tree of coroutines. Is it here? here it is. So I can see a tree of coroutines. So this is jobs. This is a job from the test scope. So this is what we the background scope that we started. Inside of it, we have our launch. So this is the launch we started on a background scope. And it has a bunch of children, so those are clearly those launches. However, if you want to verify that every coroutine has context, and you can read context at every point, on debug mode, you can see coroutine context in every coroutine, in every suspending function. And in here, you can see coroutine ID that was added automatically because we are in a debug mode, so it's a coroutine ID 3. So this coroutine, as you can see, has name coroutine 3. So the current coroutine is this coroutine. So we know that those are the children. So let's take a look at the stacks of those children. You can see they do not have stacks. They are in the created state, meaning that they never started. We just, created them and we never started them, and now we are trying to send email. So that's the problem. We are not waiting for completion of those coroutines, and we depend on their results. The simplest solution is to use a coroutine scope to await their completion, which awaits its children completion. Another possible approach, maybe a little bit more popular, more common, is to collect their jobs, await this job with join all in here. That also awaits coroutines. However, if you analyze it even more deeply, you will see that this coroutine creates purchased ebook property that we are enriching in here. So it should be even like that. So we should await this job before this action, and that also passes our unit tests. Okay, I hope you will that introduction will help you explore debugging yourself and develop your skills in doing that effectively yourself. I showed you practically all the essential tools here, so the rest is using them. There are other tools that you can use on Android. A very important tool is app inspection. You can open it in View tool Windows app inspection. You can debug your database, see what is inside of your database. You can see all the network requests in the same place, just a different tab. And you can also debug your tasks, background tasks inspector. There are other tools. I rarely use them, but they might be useful in very complex cases. Parallel stacks for Kotlin coroutines in debugger that requires a plugin that can draw you a picture of coroutines and relationship between them and their stacks. By the way, in the debug mode, the stacks has much better stack traces than in the result. Hopefully, in the future, we'll have better stack traces in the logs as well. There is also debug agent. That's a very advanced tool. I hope in the future it will be used by some libraries and tools for improving our debugging experience or testing experience. It just can get all coroutines and traverse them, display them, do anything what you want with them. So does not work on Android runtime, can be used in a local run on our test. Finally, let's talk about measurement, the last section. In Android, the most essential tools for measurements are, of course, the tools that are already given to us by Google: Android Vitals, Firebase Performance Monitoring, JunkStats library, and JunkStats helps you track missed frames, which is a very powerful tool for detecting a situation where your users' devices are not managing to display your UI. Those are very powerful tools for tracking performance on Android. When you can see some problems, or if you want to test our performance, we also have a very good libraries, micro benchmark library, macro benchmark library. We typically start them on some devices. Many companies have those farms of devices where they test their application on different devices. There are also services that allow you to delegate that. My favorite one is Smart Dust, which allows anyone in the world to connect to their network. If you have some old phone, you can connect it to their network. Then anyone will be able to test their application on your device, and you will make money on it. That's their model. So this way you can test device with any Android system with any kind on any place in the world. Pretty nice thing. They also have a bunch of users with NDAs and a bunch of own fault farms. However, this is a great topic for another presentation. We could spend whole 40 minutes talking about those tools, but this presentation was supposed to be about debugging coroutines, and performance tuning coroutines. So I would like to show you a tool that is more for testing domain layer. When I need to performance test a domain layer, the logic of our application, I implement stress tests. Those stress tests will finally end up in some micro benchmark branch. However, before they go there, I typically implement them as a simple starting points of applications so that I can nicely profile them. I typically use IntelliJ Profiler for that. So let's test those capabilities. I implemented the following. I implemented the following stress test for the service I just showed you. Here you can see some fake repositories, services. We don't want to test them, so we just make some fake implementations for them. We want to test our order service, and so we will we'll stress it, we'll make plenty of requests, and we'll see how it responds to them. I can make some simple performance measurements with measured timed value and see how much time each function takes. This is something that could end up in micro benchmark. But if I want to use profiler in IntelliJ, I can use profile with IntelliJ Profiler. Then it executes it again, but it also tracks execution and memory use and gives me a report. I can open this report, and there are two most important tabs that we are using here. There is a CPU time and memory allocations. You can see a flame graph. This shows you all the functions and the functions that are called inside those functions, etc. I most typically analyze this one. The same for memory, but it can be opened. There are details, but for the sake of showing you, it will be easier if we base on those measurements in here. I lost the profiler. I wanted to show you the CPU, but in such a case, I will just base on the memory allocations. You can see that the vast majority of memory is allocated here in create order. So what takes so much time? As you can see, calculate total order total price. Okay, so what takes so much time in here again? Nearly everything is quite cheap in here except for this tax multiplier. And here we have the reason of such a poor performance, this overly complicated function that takes a lot of memory and takes lots of time is the key reason why we waste so much memory and resources. So if I want to optimize, I should concentrate on optimizing this one. Just to show you the difference, if I start it again, let's make some very simple implementation, start our profiler again. You will see that our execution time is much faster. Our execution time is much faster. So it took half a second and less than a second. Previously, it took Previously, it took 4 seconds and still half a second because that's what it's influenced. So this is a significant difference. And again, after that, we can try to analyze it further. We can see what now takes our time and energy. So we can go into our performance test. We can see that this function that previously take majority of time now takes very little time, and it's all lightweight. Whereas this function is now more demanding. And what takes time here quite clearly, coroutines starting. Yeah, coroutines are not for free. They are way cheaper than threads themselves, but they are also way more expensive than function calls and simple operations. So you should only use them if there is a reason to do that. If you make suspending calls and there is a reason for using coroutines. All right, I hope this introduction will also help you with your own experiments. I will just give you one hint before I complete, because if you can see skipped frames on Android applications, the most common reason behind it is that you have some blocking calls on the UI thread. We, of course, should wrap all blocking calls with dispatchers IO, because if we don't, then very likely we are blocking a main thread or one of the threads from dispatcher's default. So we should wrap them. At the same time, we also shouldn't wrap suspending calls, because suspending calls will, we'll take care of dealing with coroutines correctly anyway, so that's a waste of resources. Switching a context also takes our resources. So balancing that is quite hard. Some people choose to wrap everything with dispatchers IO just to be sure, but at the same time, in most cases, we don't need to use it because practically all modern Android libraries are adjusted for coroutines, are providing suspending or flow-based APIs, and they just don't need dispatchers IO. So my general policy is, when I improve applications performance, to rather get rid of with context and then verify if I haven't missed any blocking call with a block count. That's also one of the most basic tools for consultants. Block count is a library that you are just installing in the debug mode, and then whenever you have a blocking call in a non-blocking dispatcher, like a main or a default dispatcher, it throws an exception, informs you about this dispatcher, about this situation, and so you are not missing blocking calls on significant threads. More information in block count and kotlinx-coroutines-debug documentation. Okay. There will be much more about debugging coroutines in my course, Coroutines Mastery. Some of you are probably already joining it. Then you can spread word to the others that the more of us there will be, the funnier it will be. If we have more people, we just make more Q&As. For those who don't know about it, it's the first cohort course about coroutines in the world that I created, 5 weeks long course. You will receive new lesson every day. You can connect it with a regular work. It should take around 1-2 hours a day of your own work. We'll have live Q&As with me, with creators of Kotlin Coroutines. Roman Elizarov will also be there, and current head of kotlinx-coroutines as well. It's certified by JetBrains and made in cooperation with JetBrains. There will be Android-specific lessons. We'll discuss all the different patterns for Android. So all that will be covered, and you will have a certificate from a JetBrains partner, so JetBrains certified. That was everything from my side. If you have questions, I think we have time for them. If not, then thank you for being here, and have a happy coding. Thank you.